Hello, welcome to ID3 Decision Tree Algorithms overview lecture. Suppose that this is the data set that we are going to work on. There are three different features in this data set and one decision class. These are features and class is the target value. There are STM 14 instances and decision class consists of two classes. Play and don't play, or no or yes. Firstly, we are going to calculate the entropy based on the this decision class, and for its classes which are don't play and play, we are going to calculate its probability times logarithm probability to the base of 2. Again, no and yes are classes for the decision column, or don't play and play in this table. They are same. You might think they are same. Firstly, I'm going to calculate the probability of no in this table and times logarithm of this probability minus probability of yes times logarithm of probability of yes. Esteem there are 1, 2, 3, 4, and 5 don't play instances, and total instances are 14. That's why probability of the don't play is 5 over 14 times logarithm of 5 over 14 minus probability of play class are 9 over 14, because if you count, there are 9 instances have play label. 9 over 14 times logarithm 9 over 14. Then we are going to separate the data set into sub data sets based on the classes. We are going to apply this logic for all features from outlook to windy. And suppose that our current feature is humidity, this column. As seen, there are high and normal classes in this feature. We are going to separate the data set into two sub data sets, and first data set consists of only high humidity instances, and second data set consists of only normal humidity instances. And we are going to calculate entropy for this sub data set. As seen in the sub data set, there are 4 instances don't play. That's why probability of the no is 4 over 7, because there are 7 instances in first sub data set and still 7 instances in the second data set, and times logarithm 4 over 7 minus probability of yes is 3 over 7, because as seen 1, 2, and 3 instances are play instances. 3 over 7 times logarithm 3 over 7. Let's calculate the entropy for the second subdata set. As seen, only one instance has don't play label. That's why it's probability 1 over 7 times logarithms times logarithm 1 over 7 minus probability for yes is 6 in the second data set. 6 over 7 times logarithm 6 over 7. This should be 6. There's incorrect in the original format. Then we are going to calculate the information gain for the humidity feature. That will be a global entropy. We have calculated it in here, minus probability of the subclass times its entropy. Let's calculate it. Again, entropy is calculated here, and first data set's probability is 7 over 14. 14 is the total instances in the main data set, and the 7 is the instances for the sub data set, and times entropy for high humidity. It's actually calculated here, minus again probability of the second data set. It's again 7 over 14. Is 7 is the number of instances in the sub data set, and 14 is the instances in the main data set, times entropy of normal humidity, and actually it's calculated here. In this way, we are going to calculate information gain for humidity, and we need to apply, we need to calculate for information gains for other features, for outlook and windy. And the maximum one would be my decision point, and I'm going to put the root for decision node, and calculate for its sub data sets again and again. This approach is called divide and conquer. So we have mentioned the ID3 algorithms logic, and in the following video we are going to adapt in Python code. Thank you for watching, and see you next time.